Hello students, once again welcome you to GK's maths classes. Today what we are going to do is we are going to solve LPP problem which I have already solved in part 1 of my video. Today we are going to solve the same problem, but today we are going to use a software called Geogebra, which is a freely downloadable software, and solve these problems. Okay. Now for science students you have taken only mathematics as a subject, I think for them it will be more of an enrichment to cross check whether your answer is right or not. But for people who have taken applied mathematics, you can use this as one of your practical sessions. Okay, so it's up to you. So this is actually a very good enrichment to understand how to solve LPP graphically using a software called Geogebra. That is the idea. Okay, so I'm going to solve 3 problems today using Geogebra. You can choose any number of problems. You can try to solve any problems using Geogebra for LPP. But today what I'm going to do is I'm going to solve 3 problems. One is bounded and unique solution, and I am going to solve unbounded and infinitely many solution, and then unbounded and it has no solution. So these 3 types of questions I'm going to solve, okay, using Geogebra. So I will be explaining the steps one by one. So if you can make a note of it, and then you can write it as a procedure and put it in the record book, and you can use it as a practicals. Okay. So let us straight away go inside the first problem. Okay. So I'm going to shift my screen from this to the system so that you will be able to see the Geogebra window, and I will be sitting and explaining the concepts. I hope it's okay for you. Okay. So let's straight away solve. This is a problem which I'm going to solve using Geogebra. Okay. So you can make a note of this question. Now first thing is I need to go to HDMI. Okay. Okay. Let me solve the problems. It will take few minutes to load. Just wait. Okay. Now this is the screen. This is a Geogebra window. Watch it. Okay. Now this is Geogebra I'm using, and this is called the input window. See right at the bottom. This is the input window. In the input window, I am going to type the equations. Okay. Now, what are the equations? First, my first equation is 4x plus y. 4x plus y is greater than or equal to. You see, put greater than and then equal to 80. So you get the entire region. Okay. So you are not able to see, but there is a shading. You see, it is there. 4x plus y greater than or equal to 80. The next one is x plus 5y is greater than or equal to 115. So that also has been shaded. Okay. So maybe if you go inside and see, you will be able to see that. Okay. Maybe I'll zoom out and show you. Can you see it? It's there. You can use a zoom in and zoom out to visualize. Now the third constraint is, what is the third constraint? 3x plus 2y is less than or equal to 150. See, and just press enter. So that will give you all the 3 constraints. Now type the non-negative constraints. What is non-negative constraint? X is greater than or equal to 0 and y is greater than or equal to 0. X is greater than or equal to 0 and y is greater than or equal to 0. Press enter. So you have got all the 5 constraints. 3 constraints and 2 non-negative constraints. Now what do you do? I am going to type the equation of the constraints. What are they? 4x plus y equal to 80. So I'll get that line. Then x plus 5y equal to 150. Here I am typing only equations. Okay. 3x plus 2y equal to 150. Then x is equal to 0. Y equal to 0. I have got all my constraints. So now what I am going to do is I am going to hide all this inequation. How do I hide? Go and click on this ring, this, just click on it, everything will go away. Okay, so I will hide all the constraints, all the inequalities I'm going to hide it. Okay, that I've done. Now I am going to find the feasible region. Now how do I find the feasible region? Now see, this inequalities are given a name A, B, C, D, E. Can you see it? A, B, C, D and E. So in the input box, what you do, you type A, it's actually the overlap. Overlap means and, right? It's and, it's intersection. So what you should do is, to overlap, here the command is double ampersand and. If you put double ampersand and, it will take it as intersection. B, again double ampersand and C, double ampersand and D, and double ampersand and E. I hope you understand. A and B. And means intersection. A intersection B intersection C intersection D intersection E. Now you see, I got the feasible region. You can see it very clearly. So sorry. This is my feasible region. Can you see the feasible region? This is the feasible region. The shading is the feasible region. Now, how do I find the corner points? Now select the intersection tool. Can you see here, under this, go to the intersection tool, click on that. Now click these two lines, first line and second line. You get the point of intersection. See, there's a point of intersection. Again, click on this line, click on the other line. It will give you point of intersection, that is B. Now click on this line and click on this line, that will give you the third point of intersection. Is it clear? You have got all the, and you can see these are the coordinates. A, B, C are the coordinates. Clear? A, B, C are the coordinates. Now what I will do, I want to know whether it is it's actually questions on maximize. So I want to type my Z. How do I type my Z? Use P or Q or R, whatever alphabet you want, capital letter, P of X comma Y. See, P of X comma Y equal to, what is my objective function? 6x plus 3y. 6x plus 3y. Press enter. Now what I want to do, I want to find the value of Z for the corner points. So now it's very simple. You have to put P of, what is the first corner point? A. So I got 228. Next, capital P of B. This is the second corner point. For the second corner point, it is 150. And P of C. This gives me the third corner point. Now the question is to maximize. So what is the maximum value of Z? So clearly 285 is the maximum value. Can you see it? This is the maximum value. 285 is the maximum value of Z. Okay. So let me just quickly go through this. Now, this is a Geogebra window and this is the input box. So first in the input box, what I do, I type all the inequalities. Whatever is there in the question, inequality, including the non-negative constraints, you type. And after that, what you do, forget the inequality, you type the equality. Why I am typing the equality? So that I can see these lines. Otherwise, you won't be able to see the line. Suppose it is not there, just see, I'll hide it. See, you won't see the line. You will see only the shading. So just to avoid that, I am typing the equation. Just a second. So now you type the equation. After that, what you do? You hide the inequality. After hiding the inequality, you type a command A double ampersand and B double ampersand and C double ampersand and D, double ampersand and E. Here double ampersand and indicates intersection. So A intersection, B intersection, C intersection, D intersection, E, which is the region common to all the five inequality. So that gives me this triangle, which is a bounded region. That is why I say the feasible region is bounded. How do you find corner point? You can go to the intersection tool here, click on the two lines, click on these two lines, click on these two lines, you get all the points of intersection. Once you get point of intersection, you have to define your z function. You use I have used capital P x comma y. You can use capital Q, capital A, anything you want. Is 6x plus 3y. Now what I want to do, I want to find what was my z value for this corner points. So you just type P of capital A, P of capital B, P of capital C. That will give you these values. In this, which is the maximum? The maximum value is 285. So the answer is the maximum value of z is 285 for x is equal to 40 and y equal to 15. So it's a very, very, very simple question. Is that clear? Now I am going to go to the next problem. Let me show you the problem first. Okay. So we have solved this bounded and unique solution. So what's the next problem? The next problem I'm going to do is unbounded and infinitely many solution. So you know, last class I also spoke about what you should do for an unbounded region, where you have to draw an open off plane. So I'm going to show you all that, how to do the open off plane. You are able to see visually the open off plane and also the unbounded region and see whether there is points in common. So we'll check that. Okay. So let me go to the problem. Let me first go to the HDMI. Okay. Just give me a few minutes. Let's settle down. Okay. Now I'll open a new window. So what are the constraints? First thing is, now I've got a new window. Okay. In the input box, I am going to type the constraint. What is the first constraint? 3x plus 4y is greater than or equal to 8. This is my first constraint. 3x plus 4y is greater than or equal to 8. Now what is my second constraint? My second constraint is 5x plus 2y is greater than or equal to 11. Okay. Now this is my second constraint. What is my third constraint? Non-negative condition. X greater than or equal to 0 and y greater than or equal to 0. So just like what we did in the previous problem, I am able to write all the constraints with the inequality. Now what is the next step? Type the equality. 3x plus 4y equal to 8. This is the equation. Now what you should do? 5x plus 2y equal to 11. What's the third one? X equal to 0 and y equal to 0. Y equal to 0. So I have typed all the equations now. What is the next step? As I told you before, hide all this. First let me hide it. I have hidden all the inequalities, not the equality but the inequalities. Then I want to find the feasible region. So what do? A double ampersand and B double ampersand and C double ampersand and D. So clearly you can see the feasible region is unbounded. Can you see it? The feasible region is unbounded. Previous problem, the feasible region was bounded. Here the feasible region is unbounded. Okay. Now I need to find the corner points. Now how do I find the corner points? Feasible region is unbounded. So I want to find the corner points. So for that, go to intersection tool. See, from here, go to intersection tool. click on the first line and then click on the y-axis. That will give you this point. You have got the point A. A is 0, 5.5. Now click on this line and this line. That will give you the intersection of these two lines. That is point B. Can you see it? That is point B. That is 2, 0.5. Then click this line and the x-axis. That will give you the third point C. So A, B, C are the corner points. Now what I am going to do? I am going to find my Z value. So first I have to type P, capital P of x, y equal to, what is my Z function? 60x plus 80y. 60x plus 80y. 60x plus 80y. Right? Now, capital P of A. What is capital P of A? 440. You can cross check it by doing manually also. Now, capital P of what? Capital B, vertex B. What is that? 160. And capital P of C. What is that? Again it is 160. You see, it has two same values. Remember, when it has two same values, it should have infinitely many solutions. The question is to minimize. Here the question is to minimize. So the minimum value is 160, but 160 is happening at B as well as C. Okay. But since the feasible region is unbounded, you need to draw the open half plane. Now I am going to type the open half plane. Now what is this open half plane? The open half plane is nothing but 60x. So now I am typing open half plane. 60x plus 80y. Remember, it's a minimization problem. So it should be strictly less than. Can you see? It is strictly less than. What is the minimum value? Here the minimum value is 160. Correct? Press enter. Can you see there's a dotted line? Can you see the dotted line? Maybe I'll just zoom in and show you. See, it's a dotted line. Can you see it? Okay. So this is the open half plane. Now clearly you can see open half plane and the blue region and the pink region have no point in common. Therefore 160 is the minimum value. Okay. So let us see. One more thing what I will do is, I will try to draw the open half plane for you. I will hide this for some time. See, I will hide this. Okay. I will say open half plane. How do I get? X greater than 0, that is C, double ampersand and D, that is X and Y, and double ampersand and J. J is my open half plane, and I press enter. Now you can see the open half plane and the feasible region, that is unbounded, have no point in common. Therefore 160 is the minimum value. For what value of X and Y? For all points X and Y in between BC. I'll just show you that. For all points between X and Y. So what I will do, I'll choose a point on the object. Can you see? Point on the object. And I will click anywhere in between BC. And that point is D. Now I will try to find P of D. Can you see P of D? See, it is also 160. Now what I will do, I will try to move this D. You see, that value will never change. Look at this, 160. It will never change. Can you see it? I am moving it, it never changes. D keeps changing, but my Z never changes. So when you have two same minimum value, okay, and if the open half plane have no point in common with the feasible region, then 160 is the minimum value for all points in the line segment joining BC. I have demonstrated that. Okay. So now let me once again explain this problem to you. What did I do here? First I typed the inequality, okay, as usual. Then I typed the equation of that inequality with the equal to sign. Then I hide all the inequalities. I hide by just clicking that dark dot, it will hide by itself. And then what I do, I want to find the feasible region. So I want to know what is common between A, B, C and D. So what I do, A double ampersand B double ampersand and C double ampersand and D. Again I'm mentioning to you that double ampersand and stands for intersection. So when you do that, you get the pink region. Can you see? This is the pink region, which is unbounded. Okay. Then what you do, you want to find point of intersection. So you can go here and find point of intersection. You see, this is a point of intersection too. Okay. Once you do select that, all that you need to do is see where it intersects. Okay. Let me show you that. So I find all the points of intersection. I want to know where it intersects the x-axis, y-axis, so this line and y-axis. Then select these two lines, you get this point. Select this line and this line, you get all the points A, B and C. So these are the corner points. Then what I do, I type P of x comma y. This is my z function, which is 60x plus 80y. Then I find P of A, P of B, P of C, which happens to be 440, 160 and 160. This is a question to minimize. Since the question is to minimize, my 160 will be the minimum value. But since the feasible region is unbounded, I need to draw the open off plane. Now how do I draw the open off plane? Z function, that is 60x plus 80y, strictly less than 60x plus 80y strictly less than 160. When I do that, I just show it to you. When I do that, you see, I get it. Can you see the dotted line? It's blue dotted line. Okay, that means the points on this B do not belong to J. Even though you can see B on the line, this B belongs to the unbounded region. Do not belong to J because it is strictly less than. When you say less than, line don't belong to the inequality. So I'll remove it. Okay, I don't want it. Now what do you do? I want to know what is common between x-axis, y-axis and this inequality. So you see double ampersand and D, double ampersand and J gives me the open off plane. See, this is the open off plane. Now you can see this brown region is the open off plane, pink region is the unbounded region. They do not overlap. They don't have any point in common. Since they don't have any point in common, 160 is the minimum value. But there is no 160, but there are 260s at point B and C. That means it is the entire line joining, it is all the points joining BC. Okay, let me just show you that part also once again. So I'm zooming in. Now I have an eye on this 160. Okay. So when I change B, it will never change. So BC, from the point B to C, okay, from point B to C, all the points are taken as solution. So this is unbounded and it has infinitely many solutions. What is the infinitely many solution? All points joining B and C. Is it clear? Okay. Let's go to the last problem. One more question I'll do. I will show you the problem first. So this is the problem we did, unbounded and infinitely many solution. Now the third one is unbounded and it has no solution. Unbounded and no solution. So, and this is the question. Just have a look at the question. Okay, now we are going to solve the problem using Geogebra. Let's go to the Geogebra HDMI. Okay. Now what is the last problem? Okay, let's see. First let me type the inequalities. In the input box, first I type all the constraints. What is the first constraint? X plus y greater than or equal to 5. X plus y greater than or equal to 5. What happened? Should have come. Just a second. I'm typing it. Okay. X plus y greater than or equal to 5. Okay, this is a problem. Now, what is the second constraint? My second constraint is x plus 2y. X plus 2y is greater than or equal to 6. X plus 2y is greater than or equal to 6. I have third constraint. X is greater than or equal to 3. So there are totally 3 constraints. Now non-negative constraints. X greater than or equal to 0 and y greater than or equal to 0. So all the 3 constraints are written. Okay. So totally 3 constraints and 2 non-negative constraints. Now I type the equation x plus y equal to 5. Then x plus 2y equal to 6. Then x equal to 3. X equal to 0. Y equal to 0. All the equations are typed. What is the next step? Hide the inequation. So I am hiding it. Now I need to find the overlap. So how do you find overlap? Feasible region A double ampersand and B double ampersand and C double ampersand and D double ampersand and E. So I got everything. So it's again unbounded. Can you see it? The entire blue region is completely unbounded. So now I need to find the point of intersection. I need to find the corner points. So it's a intersection of this line and x is equal to 3. That gives you point A. That is 3, 2. Then it is intersection of this line and the second line. What is that? That is B. Now it is intersection of this line with the x-axis. So there are totally 3 corner points. Correct? A, B and C. I think you can visualize it. There are 3 corner points A, B and C. Now I want to type my z function. What is my z function? P of x comma y equal to minus x plus 2y. This is my z. Minus x plus 2y. Now I want to find P of A. What is P of A? 1. Then P of B. What is P of B? It's minus 2. Then P of C. What is that? It is minus 6. Now here the question is to maximize. So what is the maximum value of Z? The maximum value of Z is 1. So I need to type the open half plane. Why do I have to type the open half plane? Because the feasible region is unbounded. Now how do I type the open half plane? Take the z function. Minus x plus 2y minus x plus 2y is greater than, y greater than, the question is to maximize, equal to 1. Why do I type greater than 1? Because 1 is the maximum value. When I type enter, you see you got a dotted line. Can you see dotted line? Okay. Open half plane. Okay. Now what I will do, I want to see what is my open half plane is. So it is the intersection of what? It is the intersection of C, that is x is, see when you say x is greater than 0 and then x is greater than, okay, I will take x is greater than 0, okay. That is D double ampersand and E and double ampersand and K. That is the open half plane. Correct? Now I will hide the K. Now you can see clearly. I just see here clearly. Just a second. Now you can see clearly the blue region. This is the entire blue region and the open half plane have points in common. If the open of plane have point in common with the feasible region, then 1 is not the maximum value. Therefore, this problem cannot be maximized. So, it has no solution. For this particular question, the feasible region is unbounded and it has no solution. Okay. Again, I'll just go through this once again. Just watch it. First, I type all the inequalities. Then I type the corresponding equalities. After doing that, next step is I hide all the inequality. Then I want to find the feasible region. So I go for A double ampersand and B double ampersand and C double ampersand and D double ampersand and E. That will give you this entire blue region. This is my entire full blue. I'm sorry. Okay. I get the entire blue region. So this is the blue region. Can you see it? The entire blue region completely you'll get. That's the feasible region. Then you go to the intersection tool. Okay. You go to the intersection tool and find the intersection. Intersection of x is equal to 3 and this line. Intersection of these two lines and intersection of this line and the x-axis. That I think you can get it. Once you got the intersection, you define your z function, which is minus x plus 2y. Then you put p of a, p of b, p of c, and you see p of a is 1, which is the maximum value. The question is to maximize. Now I have to draw the open of plane. What is open of plane? Minus x plus 2y strictly greater than 1. Can you see the dotted line? Strictly greater than 1. If you want, I can show you once again. See, this is the dotted line. The entire that. So now what I want to do, I want to find the open of plane. So how do I find open of plane? I'll take x greater than 0, y greater than 0 and the open of plane. And I got this pink region. Can you see this pink region? Now you can see clearly the pink region overlaps with the blue region. Since the pink region and blue region have points in common, h equal to 1 is not the minimum value. Because you know very well when we did problems last class, I have mentioned very clearly that if you have an unbounded region, the open of plane should not have any point in common with the feasible region. If it has point in common with the feasible region, it has no maximum if it is a maximization problem, and it has no minimum if it is a minimization problem. So in this case, even though the feasible region is unbounded, and since the open of plane have points in common with the feasible region, the question is to maximize. So 1 is not the maximum value. Okay. So with that, I will stop. I think we have done 3 different types of questions, where 3 different difficult situations where you are able to visualize these problems. Okay. So for science students, again, those who have taken mathematics only, for them, this will be more of an enrichment to cross check whether you are getting the whether you are proceeding in the right direction or not by using these tools. But for applied math students, what I advise is you can always use this as one of your practicals. Okay, you can put it in the record book. You can take any one problem or 2 problems or all the 3 problems, or you can create your own problems and try to solve it. Actually, it's very interesting. It gives you a better understanding of what you're doing. Okay, I hope this video is very useful to you. We'll continue in our next video. Kindly subscribe to my channel and also click the bell icon to get notifications. Have a wonderful day. See you again in the next class. Bye bye.